Okay, we're going to construct an unscaled graph of a tangent function. And I tell you that the tangent function is the sine function divided by the cosine function. And what I mean by this is for any horizontal coordinate on an unscaled graph of a sine function and corresponding graph of the cosine function, the value of the tangent function is the coordinate of the cosine point, the coordinate of the sine point, in other words, the length of this segment divided by the length of this segment, and of course in this case we have a positive segment and a negative segment, so it's going to be negative. I've been a little remiss in mentioning that, but we'll have to take a closer look at that. Now, I've one clear inaccuracy. The sine and the cosine function meet halfway between this point and this point. This point on the horizontal axis corresponding to 1/4 of a cycle around the reference circle. The sine and the cosine, if you think about the reference circle, sketch a good one, you'll see that the sine and the cosine are equal at the position on the arc that bisects the arc corresponding to the first quadrant. So that these two should have met at the halfway point, and this point is a little beyond halfway. It's more like 0.6 rather than 0.5. Now, I haven't subdivided this interval into equal segments. These segments are more or less equal. This segment's a little bit too big. But still, this intersection point isn't where it should be. This intersection point looks like it's pretty close to halfway between here and here. And you should, again, correspond that to the unit circle model. Okay, in any case, we're going to get started. We have to pick a unit length because we're dividing by the cosine, which means effectively that we're multiplying the sine by the reciprocal of the cosine. Now, there's actually a more efficient method for doing this construction than the one I'm going to show you, but I want you to discover that. I want you to actually do this construction. And in the process of doing the construction, you'll probably find it a little bit tedious if you do it right. And you'll look for shortcuts, and there's a slick shortcut for this that might be quite obvious to you, but it might not ever occur to you either. Okay, so here's my unit distance, and of course a convenient choice of the unit distance is just the maximum, the length of a segment that corresponds to the maximum distance of the sine function from the x, or the horizontal axis. I intentionally chose a unit that's somewhat bigger than that. Okay? Okay, so now we're going to go ahead and construct a value of the reciprocal cosine. For this point, okay, this middle point. Now, the unit is this long. I've measured that. So I'm going to sketch a line, and I can see that I'm going to have to extend this triangle. So I'm going to, you'll see in a minute, I'm going to draw the triangle kind of pointing downwards, so when we extend it, we've got enough room on the board to do it. Okay, there's our value 1, and what are we going to do? We want the reciprocal of the value of the cosine. The value of the cosine is represented by this segment. So we're going to construct, and we would construct, but yeah, just sketching. I'm not really constructing a line segment of this length. Now, in a minute, I'm going to want to extend this side so its length corresponds to 1, so that the length of this side of our new triangle, similar to the old one, will represent the value of the reciprocal of the cosine. So anticipating that, I'm going to draw the hypotenuse. I'm going to keep going And hopefully I stay along a straight line, but I didn't do a very good job of that at all. Okay, now what we have at this point is the value of the cosine here. No, the value of the cosine is here. And 1, not the value of the cosine, I'll get that off the board in a minute, 1 is here. Okay. Now what I want is I want to have a similar triangle where this side is 1. So I'm going to measure that off again. And do this. And then I'm going to sketch in my value of the cosine, which will correspond to this side of the triangle. And you should understand similar triangles well enough to understand that if this side is 1, and this side is the value of the cosine, and this side is 1, then the length of this side is the reciprocal of the cosine. Okay, now let me clean this up just a little bit. I hope I can do this without erasing too much of my picture. Okay, my 1 got violated just a little bit here, but there we go. Okay, so this green segment represents the reciprocal of the cosine. Okay, so we have the reciprocal of the cosine, and we want to multiply that by the sine. Now, how are we going to do that? Can we use triangles to multiply the reciprocal of the cosine by the sine? Now, the reciprocal cosine is just, value that corresponds to that length, and the sine is, of course, a value that corresponds to this length, the distance from the horizontal axis up to the graph at this particular horizontal position. That'll be the sine. So how could we use this length and this length to construct the product of the sine with the reciprocal of the cosine? We'll continue that in another video.